Hey guys, I'm going to run through the 5.1 through 5.2 homework. Sorry if it's a little rushed, but I really want to go and read this book. Nah, just kidding. I just want to go play my games. So, alright, 5.1 through 5.2, we're talking about... I can't remember what we're talking about. Mean value theorem and extreme value theorem. That's what we're talking about. So, state whether or not the function satisfies the hypothesis of the mean value theorem. So, meaning the conditions. So, the conditions are that it's continuous and differentiable on a closed interval. And if it does, find each value of c in the interval from a to b that satisfies this equation. So, we have this function right here on interval from 0 to 1. So when I'm trying to apply the mean value theorem, first of all, x squared plus 2x minus 1 is a continuous and differentiable function on the interval from 0 to 1. So conditions are met, hypothesis is good, we can use the mean value theorem, which states that the average rate of change is equal to the instantaneous rate of change, or at some point there has to be. And so what I'm going to start with is the average rate of change. So I'm going to find f of 1 minus f of 0 over 1 minus 0. So f of 1 is going to be equal to 1 plus 3. It's going to be equal to 2, I think. Oh man, I should really use a calculator. You guys think you're bad at math. Wait till you see me. It's equal to 2, and f of 0 is going to be equal to negative 1. So the average rate of change is going to be equal to 2 minus negative 1 over 1, and that's going to be equal to 3 over 1, which is going to be equal to 3. So the average rate of change on this interval is 3. And then what I'm going to do, so this was the average rate of change. I'm going to find the instantaneous rate of change, and the instantaneous rate of change is the derivative, so f prime of x. So f prime of x is going to be equal to 2x plus 2. And for the next part is I'm going to take take these rates of change and set them equal to each other and solve for x. So this value, so find each c, that's referring to whenever I solve for x, that's what I'm solving for. I'm finding those values of c. So 2x is going to be equal to 1, and then I'll divide it by 2, so x is going to be equal to 1/2. So at x equals 1/2, this is the value that's between 0 and 1 where the average rate of change of this function on this interval will equal the instantaneous rate of change. So this is the one time in the interval where the average rate of change, 3 is going to be equal to the instantaneous rate of change. So if I plug in 1/2 right here, so 2 times by half is 1, 1 plus 2 is going to be equal to 3, therefore they're going to be the same. All right, for 2, on the interval from 0 to 1. I think we are good on this interval. I think there's a cusp at 0 for this function right here. Let's double check. So we'll do x to the 2/3. So x raised to the 2/3, yes, there is a cusp. But if we exclude that 0, so if we're talking about from 0 to 1, we're okay. So we're still okay. We're differentiable on 0 to 1. Yeah, that's fine. And so we can still use the mean value theorem. The hypothesis is still met. So what we're going to do is we're going to find f of 1 minus f of 0 over 1 minus 0. So f of 1 is going to be equal to 1. Yeah, 1 to the 2/3 is 1. And f of 0 is going to be equal to 0. So our average rate of change should just be equal to 1. Yeah, should just be equal to 1. Yeah, definitely. You can kind of see that right there. Yeah, it's going to be equal to 1. And then the derivative, so f prime of x, is going to be equal to 2/3 x to the negative 1/3. And I'm just going to rewrite that as 2 over 3x to the 1/3. Okay, so there you go. There is our derivative. And then we're going to set them equal to each other. So 2 over 3 x to the 1/3, set that equal to 1. I'm going to multiply this up here. So multiply both sides by that. So I'm going to get 2 is equal to, oh, wait a minute. No, I'm just going to multiply by x to the 1/3. So then that would cancel here and multiply this side by x to the 1/3. So I'll get 2 over 3 is equal to x to the 1/3. And then I will raise to the 3rd power, raise that to the 3rd power. So I'm going to get x is equal to 2 to the 3rd over 3 to the 3rd, which is going to be equal to 8 over 27. So 8 divided by 27. Okay. That should be right. Something doesn't feel right, but I don't think I did anything wrong. Maybe you guys see differently. 2 to the 3rd, 2 to the 3rd is 8, 3 to the 3rd is 27. Yeah, I think I did good. Sweet. Okay, for 3, so we have x to the 1/3 from -1 to 1. I don't think this is going to satisfy the conditions. So if you have x raised to the 1/3, if we're talking about from -1 to 1, the thing is that would include 0, and at 0, this function has a vertical tangent. And so I don't think we can say that the mean value theorem is satisfied or that the conclusions are satisfied. So I'm going to say this. So you can also prove this with the derivative. So if you take the derivative, so f prime of x, that's going to be equal to 1/3 x to the negative 2/3. So f prime of x is going to be equal to 1 over 3 x to the 2/3. I'm actually kind of curious to see what that looks like. So if we say f of x is equal to that, and if I say f prime of x, yeah, there you go. So you can see how the derivative is not defined at x equals 0. There's an asymptote. So in this case right here, f prime of 0 does not exist, which means we're not differentiable at 0. The derivative does not exist at 0, which is in this interval. So state whether or not the function satisfies the mean value theorem. Does not satisfy the hypothesis. I'm just going to say hype for short, all right, of mean value theorem, MVT being also short for mean value theorem. All right, for 4, we have the absolute value of x minus 1 on the interval from 0 to 4. I'll also show this here. So if you have the absolute value of x minus 1 on the interval from 0 to 4, we have a corner at 1. So not differentiable at x equals 1. So I'm just going to say no for very, 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 very short. So cannot do that one either. Okay. For 5, use a calculator to help you with your computations. Yep. And we're just going to use the mean value theorem as well. So we want f of 1 minus f of -1 over 1 plus 1. So here's what I'm going to do. If we're using a calculator, I'm going to use Desmos. And so we're using sine inverse. Yeah, we're using sine inverse. So I'm going to go in here. I'm going to type in f of x is equal to, whoops, what is going on? Arc sine of x. So here's arc sine of x. So I'm just going to compute all this in here. So I'm going to say f of 1 minus f of -1 divided by 1 minus -1. And then there you go. So we have our, did I do that right? So our average rate of change is equal to 1.571. And then I want to know when f prime of x will be equal to 1.571. So I'll just go in here. So I'm just going to type in f prime. So f prime of x. So I have my f prime of x given there. And then I'm going to type in, how about this? I'll go up here. And I'll say y equals that, which will turn it into a function. And then I'll look for the intersection. So, there you go. Didn't even realize it. So our average rate of change right here, this is equal to pi halves, by the way. So basically we're seeing when f prime of x is equal to pi halves, and f prime of x is equal to pi halves at 0.771. So x equals 0.771. Cool. Let's do the same thing for 6. So for 6 we have a natural log function. We have the natural log of x minus 1. Natural log of x minus 1. And we are, I should put f of x, I guess. So we're going to do f of x is equal to natural log of x minus 1. And then we're talking about from 2 to 4. So I'm going to say f of 4 minus f of 2 divided by 4 minus 2, and that's what I get for that right there. So I'll say this right here, f of 4 minus f of 2 over 4 minus 2 is going to be equal to 0.549. And then what I'm going to do is I'm going to take the derivative. So I'm going to say, when does f prime of x equal 0.549? I really shouldn't be that lazy. But so f prime of x is just going to be equal to 1 over x minus 1. So when does 1 over x minus 1 equal 0.549? But dang it, this tool just works so well. 1 divided by x, I'm just going to do f prime. So f prime of x, and I'm going to set that equal to, nope, I'm going to do f prime of x. I actually don't need this anymore. So here's f prime of x, and then I'm going to do the same thing I did before. I'm just going to say when y equals that. So when x is equal to 2.820, so when x is equal to 2.820, that's when they will have the same, when the instantaneous rate of change will equal to the average rate of change. I think I did all that right, so yeah, pretty cool. For 7 and 8, so a trucker handed in a ticket at a toll booth showing that in 2 hours he had covered 159 miles on a toll road with a speed limit of 65 miles per hour. The trucker was cited for speeding. Why? So here's a small application for the mean value theorem. So what's happening here is that what we're going to do is calculate the average speed. So the trucker went 159 miles in 2 hours. So 159 in 2 hours means that his average speed was equal to 79.5 miles per hour. This was his average speed. Now, his speed has to be differentiable and continuous. There's no like jumping from like 2 miles per hour to all of a sudden going to 60 miles per hour. There has to be it has to be continuous, and it has to be differentiable. So in that case right there, his average speed was 79.5. So by the mean value theorem, if his average speed was 79.5, that means at some time in the 2 hours, he had to have been going 79.5 miles per hour in a 65 mile per hour zone. So by the mean value theorem, his average speed was 79.5. So the trucker had to reach that speed at least once in those 2 hours, which would obviously mean that he had to exceed 65 miles per hour. So, but anyways, that's why the trucker was cited. It took 20 seconds for the temperature to rise from 0 degrees Fahrenheit to 212 degrees Fahrenheit when a thermostat was taken from a freezer and placed into boiling water. Explain why at some moment in the interval the mercury was rising at exactly 10.6 degrees Fahrenheit. So let's just find the average change in temperature. So we go from 212 minus 0 over 20 minus 0. So the change in temperature over the change in time, and that's just going to be 212 divided by 20, which is 10.6. So 10.6 degrees Fahrenheit per second. And so because the average change in temperature was 10.6 at some by the mean value theorem, the instantaneous rate of change so because the average the instantaneous rate of change was 10.6 degrees Fahrenheit per second at some point. At some point in those 20 seconds. So there you go. All right, so for 9, 10, 11, 12, we're talking about the extreme value. So find the extreme values of the function and where they occur. So what we're going to do now, these aren't on any closed interval or anything, but we're going to find where these where the extreme values are. So if you guys remember, we talked about extreme values happening at critical points. And critical points are where the derivative is equal to 0. Yeah. So find the extreme values and where they occur. So let's find the derivative. So y prime is going to be equal to 4x minus 8, and we're going to set that equal to 0. So 4x is going to be equal to 8. Therefore, x is going to be equal to 2. So where do they occur? That's at x equals 2. And what is it? What you're going to have to do is plug 2 into the function. So y is going to be equal to 2 times by 2 squared minus 8 times by 2 plus 9. So that's going to be equal to 8 minus 16 plus 9. That's going to be equal to negative 8 plus 9, which is going to be equal to 1. And so extreme values happens at 2, and the extreme value is 1. For 10, so y prime is going to be equal to 3x squared minus 2. We're going to set that equal to 0. So we get 3x squared is equal to 2. We get x squared is equal to 2/3. we get x is equal to the square root of 2/3. Now, since we are talking about a function and negative numbers aren't restricted, that could be plus or minus square root of 2/3. And I'm feeling really, really lazy and wanting to go read my book, so we're going to just graph this right here. So x to the third minus 2x plus 4. Okay, so you can see we have those values right there, and even if you do this right here, so we said the square root of 2 divided by 3, right? So there's the square root of 2 divided by 3, so you can see that the extreme values happen at both the positive and negative, and the extreme values are 5.089. So y equals 5.089, and the other one is 2.91. What did I say? 2.911. Okay, and those are the values that it happens at. Cool. All right, so for y prime here, we're going to have 3x squared plus 2x minus 8. Oh, goodness. I do not want to factor right now. Okay. So we have a quadratic. We're setting equal to 0. We need a factor, but there are no easy factors. So we can't factor out of 3. So we do 3 times negative 8. That's negative 24. What multiplies to be negative 24, but will also add to be 2. That's going to be equal to positive 6 and negative 4. So I get 3x squared plus 6x minus 4x minus 8. And I do factor by grouping, so I can take out a 3x. I'm going to be left with x plus 2. I can take out a negative 4. I'm going to be left with x plus 2. So then I get 3x minus 4, and then I get x plus 2. So I factored. That wasn't too bad. So then I can solve these for 0. So that's going to be at x equals negative 2 and at x equals positive 4/3. And again, I'm just going to go right to graphing this right here for the sake of time. So we have x to the third plus x squared minus 8x and plus 5. All right, let's verify these values. So at negative 2 and at 1/3, we are correct. We do have them. So it's 17 for one of them. So y equals 17. And for y equals negative 1.519. Negative 1.519. And finally, one more. So for y prime, that's going to be equal to 3x squared minus 6x plus 3. Oh, I can factor out a 3. So y prime is going to be equal to 3. We're going to have x squared minus 2x plus 1. So that's going to be factorable into x minus 1 minus 1. And so when that's equal to 0, so it's only going to be at x equals positive 1. That's not bad. I can plug that in. So that's when y is equal to 1 minus 3 plus 3 minus 2. So 1 minus 2, that's going to be equal to negative 1. Just to kind of prove that we found it. So we have x to the third minus 3x squared plus 3x. And was it plus 2? No, it was minus 2. Uh-oh. So we still have 1 and negative 1, but it's not an extreme value. So good thing we checked it. But we also don't really care to check it in 5.2. That's what 5.3 and 5.4 are for. That's for checking. So I kind of didn't mean to put this on here is what I'm saying. So whatevs. All right, so I'll go over the multiple choice in a second video.